just revise what we said we will be asking. That is the areas that you guys should be concentrating. So as I said the other time, I said you will be given multiple choice questions. Okay, some questions you will be given P, I, N, and then you will be asked to find F. That is, you'll be given the principal amount of money, you will be given the interest rate, and then you'll be given the number of years, and then you will be asked to find the future good. So everything will revolve around this area. All what you need to know is to identify what is P, what is I, what is N, and then you can find F. N is number of years, so you can see 2 years, 3 years, something like that. I is interest rate, so you can see at the rate of 2% or something. This is the principal. They will say you have invested so amount of money, so that is the principal. And F is the future amount of money, so they will ask you how much will you be expecting to get after 5 years. So F is what they are asking you, and then the 5 years is N. This should be well understood. And what this formula is saying literally is that you are given P and you are asked to find F. So you are given the denominator, which is what we are given here, and you'll be asked to find F, that is the numerator, and that is the formula that is given here. And if you want to use the table, it is there also, you can use it. Okay, for me here, I just wrote an Excel formula, and then everything you can easily calculate it based on the interest, principal amount of money, and that and then you can find the end. So you can develop this kind of formula for the purpose of your calculation also. F over P. The meaning of F over P is that you are given P and you are asked to find F. That is the meaning of F over P. Then the other table, that is, you will be given F and you will be asked to find P. And that is what you have here, the red one. You are given F and you will be asked to find P. So in this case, you will be given I, you will be given F, and you will be given the future amount of money, and then you will be asked to find P. So this is what they will be saying, for example, how much is how much is Bakar or Muhammad or something, how much is he supposed to invest now in order to get this amount of money in the future after 3 years at the interest rate of this. So you know, you are asked to find P, that is what they are asking you, because they want to tell them how much should this guy invest now to guarantee him this amount of money in the future after 5 years at the interest rate of this. So this is what you just need to do. And you can see, if you write an Excel formula, everything will be easy for you. You have the formula here, you just plug it in here the way it is written, and then you have the answer. For example, this is D, this is I, and whatever. So I don't want to give you a clue of how you do that, but you can just come up with an Excel formula that will make your life easier during the quiz or during the exams. Then the other question is, you are given A and you'll be asked to find P. So you are given the denominator and you'll be asked to find the numerator. So the denominator is the amount of money, and then you'll be asked to find the P. But maybe you'll be given amount, interest, number of years, and then you will be asked to find the principal amount of money that you need to invest in order to have this kind of whatever. So in this case also, you just come up with this formula, you put it here, and then everything is easy. You just plug in your details here, and then you have the answer at the end of this thing. So this is really easy. You can plug in this kind of your formulas on Excel, and then you make everything easy for yourself. And again, we will give you a question given P, find A. This is given A, find P, and this is the reverse. You'll be given P, you'll be asked to find A. And every time you want to translate this kind of formulas, it's like you are given the denominator and you'll be asked to find the numerator, just the same thing, the way you have it here. So you have P, you will be looking for A, given I and N. So you just plug it, and then you have everything ready for you. So these are the two main formulas if you are given for this uniform, 3 main formulas for this uniform series. The other scenario is you'll be asked to find F given. So whatever, if you are given A, you are asked to find P or F, then you use one of these two. If you are given P, you are asked to find A, use this. If you are given A, you are asked to find P, then you use this one. So I hope this is really clear and very easy for you guys to come up with something like this. Then coming to the gradient formulas, you will have, at least you will have some questions from this single amount of payment, this single payment stuff. Then you'll have some questions also from both of these guys. And then you will have another question under this gradient formula. Under gradient formula, you will be given a question on arithmetic gradient and then a question on geometric gradient as well. So for arithmetic gradients, you'll be given the amount, the interest, the number of that is the NA at this amount, the number of years that you'll be receiving this amount or that you'll be injecting this amount. Then the gradients will be given, which you plug it in, and then you can have either the present gradient or you'll calculate the amount given this. You calculate P given this amount, and also you can use it to calculate the present total. So it depends on what kind of question you will be asked. So whatever the question they will ask you, you should make sure that you are ready for this kind of questions. Then the other one is on arithmetic, on geometric gradients. So maybe you will be given I, you will be given N, and then you will be given the gradients. And then you will be asked to find the present gradients. So you just use this kind of relation to do this kind of to execute this kind of task. So these two questions, these two type of questions would be definitely included in your exams. So you should pay attention to it and know how to maneuver it in case if you come across any of the questions. Just a second, please. Okay, you'll be given again another question on shifted arithmetic gradients. So you just remember all the formulas and how to do it. A, I, N, A, N, J, and G. So you just plug it and then you find whatever they ask you to calculate. And at the same time, the one for geometric gradients, you can use this kind of relation to calculate whatever you are asked to calculate. So I hope this is understood, and you can easily use it for your exams. So I have the exams and then the quiz. So if any of you will be successful in hacking my computer, then you will have the questions. Okay. So you can hire my daughter here. She's a hacker. She's a computer hacker, so she can help you do that. Okay, so that is it about the quiz. And then let's just complete chapter 4 and then maybe start introducing chapter 5 to you. So the last time we looked at a scenario where you have a single payment, a single amount where payment period is greater than or equal to compounding period, and we explained how to do this kind of calculations. Then we also spoke about a scenario when you are given a series of payments and then the payment period is greater than the compounding period. And then we said these are the steps in which you can do this kind of calculations. So today we will be looking at a scenario when you are given the payment period less than the compounding period. And so what will you do and how you will do this kind of calculations. And this is the last subtopic under this chapter. So if you are given this kind of series, then what you need to do is positive cash flows, you will move them to the beginning of the interest period. So when you are given this kind of scenario, you just take your positive cash flows, that is they think that the arrows moving up, you move them to the beginning of the interest period, and then the negative cash flows, you move them to the end of the interest period. And once you do that, you can calculate P, F, and A values using the effective interest rate per payment period. We will look at all this in the example in the next page, and things will be clear to you when we look at the example. So this guy, they say a person deposits $100 every month into a savings account for 2 years. So he's depositing $100 every month into his account for 2 years. So you have 1, 2, 3 months, monthly, up to 24 months, that is 2 years. And what he's depositing is uniform amount of money, that is $200 on up to that 2 years every month. So they said if $75 is withdrawn in month 5, so in the month of 5, they withdraw $75, and also in the month 7, he withdraws $75, and 8, he also withdraws $75 in addition to the deposits. So this is the information. They're asking you to construct the cash flow diagram, the flow diagram of the cash, and to determine how much would be in the account after 2 years. So how much would be in the account after 2 years? That is the future total here after 2 years at this 24 years at the interest rate of 6% every year, compounded quarterly. So the CP now is quarterly. Okay. Assume that there is no interperiod interest, so there is no any interperiod interest. So this is the information that they gave. So you draw it like this, and then now you need to construct the real cash flow diagram. So you remember here we said positive cash flows, you move them to the beginning. So to the beginning of the interest period. So everything you get, you take them to the beginning of the interest period. So here they said he got $75 here at month number 5, another $75 at the month number 7, and then another one at the month number 8. So, and the compounding period, that is the time they are getting this compoundment, is quarterly. So how many quarters in a year? That is, you will have something like 33 years. So you move the positive cash flows to the beginning of the quarter, so positive cash flows, you moved it to the beginning of the interest period. So this is the beginning of the interest period. And then the negative cash flows, you moved them to the end of the interest period. So this month number 3 coincides with the end of the interest period. So all the negative cash flows, you add them together, and then at the ending of this interest period, you add them up. So 100 plus 100 plus 100. At month number 3, you must have deposited 300. Also, if you add 4, 5, 6, and on number 6, you deposited another 300. Then 6, 7, 8, 9, you deposit another 300. At 12 months, that is, you have quarter 4 deposits. You deposit another 300. Then up to this month, that is when you will have 8 quarters. At the month of number 24, you deposit another 300. And then for the positive cash flows, so this is month number 5. So you move it to the beginning of the interest period. So the beginning of this interest period coincides with the end of the other period. So you move whatever you get from here, you move it to 3. And then whatever you get here in this interest period, you add them together and you move them to this beginning of this interest period. So that is why you have 75, you move them to 3, that is the end of this interest period. And then 75 plus 75, which is 150, you move them to the end of, to the beginning of this interest period, that is month number 6. So that is how you construct the new cash flow diagram. And so for the calculation, the first thing you say is you find the relationship between PP and CP and see what kind of calculations you will make. So based on this, then we are done with this number 1, then you move to rule number 2. And for that, you see which one is greater? Is it PP is greater or CP is greater? So the payment period is monthly. You are paying every month, 1, 2, 3. So the interval will be every month. So, and then the compounding period will be quarterly. So compounding period is greater than the payment period because this is 4 months and so on. Then the second step that you need to take is to make a nominal interest rate with same compounding period. So you need to calculate the nominal interest rate with the same compounding period. So the nominal interest rate is given 6% per quarter. 6%, they give you 6% per year, but the compoundment is done quarterly. So you need to convert this into a quarter basis. So the interest rate per annum is 6%. You divide by 4 months. That will give you the interest rate, the nominal interest rate per quarter. And once you find this, if you remember our formula, that you can convert your nominal interest into an effective interest rate using the nominal interest rate and then the number of periods, that is the quarter. You plug it in here, -1, you have your effective interest rate. And once you determine the effective interest rate, now you need to calculate the N. The N should be the same as the compounding periods now. So the number of years, they said for 2 years, yeah? They are asking for what will be in the account after 2 years, for 2 years. So that is what you need to convert. You need to convert the years into quarters because you are given the compoundment as a quarterly basis. So whatever you have here in the year, that is 2 years, you multiply by 4 quarters. You have 4 quarters in a year, 2 quarters in 1 year, 4 quarters in a year. So if you want to convert it, 4 quarters, you multiply by 2 years, and that will give you 8 quarters in 1 year. So in 1 year, you have 8 quarters, and that is what we have here under this 1 quarter, 2, 3, and up to the 8 quarters at the end of our second year. So then the fifth step is to solve for A series. So you have the amounts here, 300, 300, 300, 300 for 8 quarters. So the amount is 300. You are given amount, you need to find the future amount. So you are given A, which is 300, with this interest rate that you just calculated, the effective interest rate here. And then the number of quarters, that is 8 quarters. So you find FA, that is the future amount. Once you calculate that, then you need to calculate F for single payments. So you put 75 here. That means you have 7 periods ahead. So because you remove 1 period, and the remaining quarters, you will have 7 quarters. Yeah. So the end will be 7 quarters, and this is your effective interest rate. So you need to find the future amount. And so for 150 also, you remove this, so you have 6 more quarters. So the end will be 6 quarters. Once you have this, your total for the future is the addition of this one. And for this one that you will have, you subtract these 2 from it, and that is your F total. So I will advise you again, when you are reading this kind of when you are reading this chapter, you try to come up with an Excel version of this kind of formulas. Just put everything inside, so you can calculate everything automatically once you give this kind of values, and it will convert everything for you. So these are some examples that you can work on in your leisure time, and that is it. That is the end of this chapter. So in chapter 5, we will be looking at what we call present worth analysis. So we'll just introduce this just 5 minutes or so, and then I will let you guys go because of so you can. We have asset prayer also, and then you can also concentrate on revising your exams. So present worth analysis. Present worth, what you have now, and then that is the analysis we'll be making. A future amount of money converted to its equivalent value now. So if you have any future amount of money and you want to convert the equivalent worth of that money now, is what we know as the present worth. That is what you have now. What will that future amount of money amount to now? That is what we call the present worth analysis, and that is always less than the actual cash flow. So present worth values are often referred to as discounted cash flows because, so just imagine what you have now, like 10 years for today is less than, the value of 10 years today would be different from the value of 10 years tomorrow or the next year because of inflation and so on. So what you will buy with 10 years today might be different from what you would buy with 10 years tomorrow. So what you are trying to do is that future amount of money you want to calculate the equivalent now, and for that reason you will always have less than the amount. So if they give you, if they say the future worth of the money, or the amount of money that you will have in future is 12 reals, and if you want to know the equivalent of that money now, maybe you will say it is 10 years. So for that reason, this value of today, they are usually referred to as discounted cash flows. They are less than that of tomorrow, so they are discounted. Similarly, interest rate is referred to as discounted interest rate. So the interest rate will also be lower than what you will have in that future. So besides present worth, equivalent terms frequently used are present value. Sometimes they use PV in place of this present worth, that's present value, and net present value. Sometimes they use something like this. And up to this point, present worth computations have been made for one project. So most of what we do is on one project. In this chapter, techniques for comparing two or more mutually exclusive alternatives by present worth methods are related. So we will define what we mean by mutually exclusive events. I mean, you know this in probability in mathematics, but also we'll look at it from economics perspective, which is very similar to that of mathematics. Next class. Additionally, techniques that evaluate capitalized cost, life cost, and independent projects will be discussed. So next class we will be looking at what is an alternative. We have already started discussing about that, and then under this we'll be looking at mutually exclusive and also independent projects. So if you remember in your probability mathematics, you have mutually exclusive events and then independent or mutually exclusive events, and so on and so forth. So we'll just build on that, and then we will discuss these two terms in an economics perspective. So that is it for today. And if you have any question, please go ahead. Okay, guys, you are all welcome, and I wish you all the best in your exams. The exams will be on Saturday at 11 o'clock, and it will be online on the Blackboard. So, you should all attend. Okay, I will send a separate announcement regarding that on the Blackboard. How many questions we have not decided yet, but maybe, I don't know, we have not decided yet, but it will be a power pool bank, pool questions. So the questions you will have might be the same or might be different from what the other guy will have. I will confirm about the number of questions, and then I will let you know, inshallah, today. I will send an announcement regarding that today in the online evening. Okay. So all the best in your exams, inshallah. And also please look at chapter 1 properly. The first few classes on chapter 1, maybe calculate the interest rate given n and whatever. So it will be easy. So just chapter 1, the beginning of the first 2 pages of chapter 1, of first few pages of chapter 1. Okay, so all the best in your exams. All the best. You can leave now. You're welcome.